In this video we are going to see an application of Chebyshev's integral inequality. So the exercise, a small exercise here, is to prove that this polynomial 2x minus x squared is bounded by the function x squared plus 2x times the exponentially decaying function e to the power of minus x. So let's start with the Chebyshev's integral inequality. It says the following, that if you have the integral from a to b of a function f of t times the integral from a to b of the function g, like this is bounded by b minus a times the integral from a to b of the product of the two functions f times g. And this holds provided that f and g are positive functions and they have the same monotonicity. For example, they should be either monotonically increasing, both of them, or it should be monotonically decreasing. They should have the same monotonicity for this inequality to appear. Otherwise, the direction of the symbol, so otherwise the inequality is reversed. It's gonna be this bigger than that. But let's start with that one. So let's consider two functions. So here we're going to adapt the Chebyshev inequality. We are adapting the Chebyshev inequality like this. So the lower bound is 0 and the upper bound is x. And now we have to take the functions. Let's take f of t equals e to the power of t and g of t equals t. These functions are positive. These functions, f is positive for t belonging 0x and g is positive for t belonging 0x. Now about the monotonicity, the derivative of the exponential is positive. The derivative of g is 1 is positive. So f and g are monotonically increasing functions. They share the same monotonicity. Now let's put things together. Let's calculate the left and the right hand side. Left hand side is the integral 0x ft dt times the integral 0x g of t dt. F of t is e to the power of t. G of t is just t. So that's gonna be, I can compute the integrals explicitly. So my left hand side is e to the power of x minus 1 x squared over 2. Now let's compute the right hand side. The right hand side is x times the integral from 0 to x f of t dt, f of t g of t dt. I need to do integration by parts here. So I'm going to have t e to the power of t 0x minus the integral 0x e to the power of t dt. x e to the power of x minus 0 e to the power of 0 minus e to the power of x minus 1. That's going to be x e to the x, this term vanishes, minus e to the x plus 1. So that's x squared e to the x minus x e to the x plus x. So that's my right hand side. Let's put the inequality together. The left hand side is e to the power of x minus 1 x squared over 2 less than or equal to x squared e to the x minus x e to the x plus x. Let's multiply both parts of the inequality by 2. E to the x minus 1 x squared less than or equal to 2x squared e to the power of x minus 2x e to the power of x plus 2x. And let's expand the bracket at the left hand side. X squared e to the x minus x squared less than or equal to 2x squared e to the x minus 2x e to the x plus 2x. Okay, now we have to move terms. Let's move terms. So we have, let's move this to the other side. We have x squared e to the x minus 2x squared e to the x plus 2x e to the x, and this becomes x squared plus 2x. So that is going to be 2x e to the power of x minus x squared e to the power of x less than this polynomial. Let's take common factor the exponential. Now multiply by e to the minus x and you have 2x minus x squared less than or equal to x squared plus 2x e to the power of minus x, where x is from 0 to infinity. And that's our final inequality. So that's of the form mu of x is bounded by lambda of x times e to the minus x. That's inequality of this form, where mu of x is 2x squared, 2x minus x squared, and lambda of x is x squared plus 2x. It's a very useful Chebyshev integral inequality is a very good inequality. Otherwise, you can prove this inequality by taking all the terms to one side and define a function and take the derivative of the function, and this is very computationally intensive. Whereas here with Chebyshev integral inequality, provided that the functions are non-negative and have the same monotonicity, then you can derive some fancy inequalities.